Hey physics fans! Today we are learning how to calculate the coefficient of friction. And to do this, we are going to be looking at the amount of friction it takes to keep a block moving at a constant speed. In this diagram, we have a block sitting on a flat surface with a mass of 5.5 kilograms. The weight of the block is straight down toward the center of the earth, and to calculate the weight, we take mass times gravity. So the mass of 5.5 kilograms times negative 9.81 meters per second squared, which is the acceleration of gravity, gives us a downward force of negative 54 newtons. Looking at the normal force, this is always the opposite of the weight. Instead of the block pushing down on the flat surface, it is the surface pushing back up on the block. That is what we're going to use to calculate the amount of frictional force. To keep it moving in a straight line, we have to pull in one direction. This is the parallel force, and it is shown in the diagram with the red arrow to the right. As long as the speed remains constant, the frictional force and the parallel force will be equal. If the parallel force equals the frictional force, it's pretty simple to calculate the friction. The frictional force is equal to the normal force times the coefficient of friction, which is shown as the mu symbol. This we're going to calculate now. So let's take a look at this experiment in the physics lab.
They set up with a block, 5 kilograms and a half kilogram block, which gives us a total of 5.5 kilograms, which is the 54 newtons, pushing straight down. The plane is pushing straight back up with an equal amount of force, Newton's third law, of 54 newtons. I have a spring scale attached, so that way I'm going to pull it at a steady speed. And I'm getting an average force of right around 30 newtons. So the parallel force is equal to the frictional force, which is 30 newtons. Taking 30 divided by 54 newtons, because that is the normal force, gives me a coefficient of friction of 0.56. Now this is a dimensionless number because the newtons, the units, all cancel out, just like pi is a dimensionless number. But where did the energy go? The energy went into heat. Now, we've all known and been told that if you rub your hands together, it gets hot because of friction, but let's actually see if we can see the heat. So we're going to redo the experiment, but we're going to use a thermal imaging camera and check to see what we can see on it. Okay, the same experiment, but with the infrared camera. And you can see the trail of heat left by the friction.
Let's review a few key points from the video. The coefficient of friction uses frictional force, the parallel force, and normal force. Normal force is always opposite of weight. Weight equals mass times gravity. At constant speed, frictional force equals parallel force. Frictional force is equal to normal force times the coefficient of friction. Remember, the coefficient of friction is a dimensionless unit. Well, there you have it. There's our physics lesson for today, the coefficient of friction.